Hi there, I'm Hao, and this is just another video of me solving randomly code problem. So, given the root of a binary tree, we have to determine if it is a valid binary search tree or not, right? And a valid binary search tree means the left children have to be smaller than the parents, and the right child has to be greater than uh, the parents, right? And then we cannot have duplicate inside our binary search tree. And both the left and the right subtree must also be binary search tree. Okay. As we can see here, right? Not only that, we have to compare with the two child, but we also need to compare with the grandparents, right? So let's say, for example, this is 6, it is 8, right? Which is valid. But here, even though 3 is smaller than 6, right? But it has to be bigger than 5, right? Because anything on the right side of 5, the children of parent 5 have to be greater than 5, right? Greater than the parent to be a valid binary search tree, right? So what we can do is we can keep track of an a range, our interval. So we can start out at negative infinity to infinity to make sure everything pass on the first node, right? So 5 is in the range, right? So that is valid. So if, as we iterate through the left and the right, right? Uh, if we go left, the lower bound stay the same, but the upper bound becomes 5, right? So 1 has to be smaller than 5, right? Because we cannot have duplicates. So 1 is in the range, right? So it's valid. So we keep looking to the left and the right of 1, right? And if it is no, then we return true, right? So we return true and true. So we return true up here, right? So we look on the right side. So our interval will be the upper bound stay the same, but the lower bound become 5, right? So 4 is smaller than 5. So it is invalid, so we return false here, right? True and false give us false, right? Because the left and the right subtree must be binary subtree, right? So both left and right have to be valid. If either one is false, then we return false. Okay, so that is our strategy. Let's code this up. Okay, so we need a helper function. Helper function, and we're gonna have the roots, right? Or the node. Let's call it parent, or just parent, right? And then a low and a high, low and high. Okay, and we can return the helper function. Helper, we're starting at the root, negative infinity, and infinity, right? Infinity, right? So if uh, parent is null, we can return true, which means we have reached all the node, and there's no children left, so we return true. And if the parent's value is less than or equal to low, or greater than or equal to high, remember, we are not allowed duplicates, right? That's why we have the equal sign there. We want to return false. Right? Otherwise, we keep iterating to the subtree, right? Both the left and the right have to be valid. So current dot left. If we go left, the lower bound stays the same, but the upper bound becomes the current dot bound. And if we go right, um, the lower bound become current dot bound, but the upper bound stays the same. Okay, so let's give it a try. Wrong answer. Expected false. 51436. So we start at the root. Okay. The lower bound is negative infinity, upper bound is infinity. If we don't have the parent, uh, okay, we can return true. If the parent is less than or equal to low or greater than or equal to high. Oh yeah, parent of val, right? Just a typo there. Okay, still we return false. Otherwise, we go to the left, right? We pass in the root dot left, parent dot left. The lower bound is the same. Upper bound become parent bound. Right here, we have the lower bound, upper bound, but we forgot to pass in the right subtree, right? Okay, let's try it again. Okay, now it passed. And thank you for watching.